Okay, in the last video, we applied all of the things that we've talked about in this section. We've taken a look at how we could go about defining a class. Then we saw how we could take that class and actually create an object from it. And then we saw how we could take that object and let it think for itself in an environment, our environment being the console, and we were basically able to put it into motion and let it just do its own thing. And because of that, it took care of just simply bouncing around the screen. Now, what did we actually have? We had a loop, and inside the loop, we basically called upon that item to update. And, of course, in calling upon the item to update, internally, it took care of checking to see, did we hit a wall, do we need to reverse our velocity, yada, yada, yada. And that's very convenient. But the problem we have at the moment is the way that we're handling the objects. We are, inside the loop, addressing the objects individually. What does that mean? Well, if we decide to go and put another object in, and let's just pretend that this guy had a character of Y, and he's going to start bouncing around. That means that we're going to, inside the loop, have to address that particular individual. Okay, not necessarily a problem if we're only dealing with a few objects. And we know throughout the life of the application, that's the only objects we're going to be dealing with. But what happens if we're in a game-like scenario and these objects are, for instance, enemies? And as we progress further and further into the game, enemies spawn in. So we suddenly start getting more and more enemies. Like, let's say during application execution, A is to spawn in, and he needs to start bouncing around. Okay? Well, A needs to end up being updated somehow inside of our loop. Well, is somebody going to go in there during application execution and add A into the loop? Well, we can't do that, obviously.
Right, the scenario would no longer be dynamic. In any case where you're hand-coding each individual object, you're going to run into a scenario where you have to have the max amount of items accounted for, which means that if you took the time to make 25 different objects, you could basically have a max of 25, but you couldn't exceed that because there's no code for more than 25 to exist.
Exactly.
Not to mention the fact that it becomes a lot of work. For example, if suddenly you have to have 500 objects, you suddenly have a lot of work in front of you.
Yeah, without a doubt. So that's the problem we have. We need to be able to manage a bunch of these objects, an unspecified number of these objects. So let's say going in as the programmer, we don't know how many enemies we're going to have on the screen. Let's say that we happen to have a really amazing player play the game, and he could spawn hundreds and hundreds of enemies. And of course, what happens as the enemies die? You don't want to have to go and put special code in here checking each of these objects individually to see if it's dead, and if it is, then don't call upon its update. That becomes a tremendous amount of code that's going to be added. And once again, backing up what Logan just said, if we had 500 different objects, you don't want to repeat that code 500 times. It just isn't necessary. It's definitely not efficient, and managing it is near impossible. So we need some other way of handling all of these objects. What we're going to do is we're going to talk about the ListGenericClass. Let me go ahead and jot that down. The ListGenericClass. Now this is kind of interesting. This is, for the first time, us working with generics. But we're not going to get into generics right now. And there's a very specific reason why. And that is, I don't want to introduce generics until you truly understand why generics are so important. The only way for you to understand why generics are so important is to put you into situations where you're going to have to, let's say you create a class and that's going to work with a particular object type, and then you find yourself having to work with another object type, and now you're going to have to redefine that class. That is just a really quick example. And having to go in and redefine the class, you're doing all of this work, it really does make managing different types of objects a complete pain. So once you've done that by hand, though, and then someone introduces you to generics, then you're like, oh, wow, man, life is so easy with generics. And it makes it crystal clear in regards to the understanding of what generics are. Now, the ListGeneric class is extremely powerful, and it's going to give us the exact functionality that we need right now. So I'm going to introduce you to this class. We're going to talk about what it does, and we're going to walk through some of its properties and definitely a good bit of its behavior, and then we're going to implement it back inside Bouncing X's. But just keep in mind, the idea of this particular video is not to get into generics itself. That is something that we're going to do later. I just want you to become very comfortable working with the ListGeneric class, okay? So, in this video, now that we kind of know the problem that we need to solve, we need some way of managing a whole bunch of these objects. What are we going to learn? Well, first of all, obviously, what exactly is, so what is a ListGeneric class? Next, we need to understand the syntax. Next, how to go about working with lists. How do we use this class? Now, there's quite a few different things available within the class in regards to the state it can be in at any moment and the behavior that is available to us. We're not going to be covering all of that. That's not the idea. The idea of this video is to introduce everything we're going to need to be able to handle the problem that's been demonstrated over here with our application, which is managing a bunch of different objects that are all of the same type. So, what do we need to do in regards to working with lists? Well, first of all, we need to know how to create a list. The next thing we're going to need to know, and most obvious, is how to add items into the list. And if we understand how to add items, it'd be very helpful to understand how to remove items from the list. Next, how do we access items individually? And I'll just put access items in the list. All right, next, how do we determine the number of items that we have in a list? Obviously, that's going to become important at some point. So I'll just call that getting the count. And then finally, how do we go about looping through all of the items in the list? So let me just put down looping. Actually, I'll put looping through objects. Or items. That makes more sense. And there's two different ways that I'm going to show you how we can do this. I'm going to show you how we can do it with a for loop. And I'm going to show you the for each that was actually mentioned all the way back in the looping videos that we had in an earlier lesson. Okay, we didn't actually go into how for each worked, and I told you later on we were going to see how to use it. Well, we're going to learn how to use it in this video. So that's what we need to cover. So several things. So this video might end up becoming lengthy. I'll do my best to keep it as short as possible, but very much to the point. So starting out, what exactly is a list? Well, let me give myself another sheet of paper here so I can do some more scribbling. A list, first of all, you see that it is a class. So it's going to be an object that we're going to instantiate. And this object is basically going to manage a list of objects of the same type. That's the goal. And that is, of course, what we're looking for. So that's a good thing. So let's say that we have a class called enemy. And from this class, we happen to instantiate 3 different enemies. So let's say that we had a spider. Let's say that we had an axeman. Yeah. That sounds kind of scary. And not man, though. So, man. And then finally, let's say there's some sort of mad dog. We'll just say dog. Okay, so here we are with 3 different objects. Now, it would be very cool if we could have some sort of object that basically pointed to each of these guys. So, for instance, we're going to point to this guy. We're going to point to this guy. And we're going to point to this guy. And at some point, if I decide to go about instantiating the enemy class again, and we happen to have a killer bird, it would be nice to add that bird into our dynamic list so that we can then address him as we walk through all of the items in the list. So that's kind of what we're trying to accomplish here. We want this list. And of course, this list is going to be instantiated, so it'll be called something. I mean, we could call it enemies. So we could say enemies.add, and we can add the bird into the list, and then the bird's in the list. Now, of course, we need to be able to walk through these. So inside the list, each of these guys are going to be numbered, and it's going to start off with 0. So there would be 0. That would be 1. That would be 2. And this would be 3. So as you can see, it's not that it's not like we're putting the objects into the list. It's more or less, in the list, we're managing a bunch of references pointing to objects.
Right, we're making a one consolidated list that holds where all of our objects are at. Because if you think about where the objects are actually at in the heap, they, as far as you're concerned, are just scattered randomly throughout the heap. And unless you have individual variables, that's the only way we've looked at so far is how to find those objects.
Exactly.
A list makes a place to put all of these objects where we can run through in order by number.
That's right.
Say, all right, we have a lot of objects in this one convenient, easy-to-read list.
So a list is just an object, which means in regards to working with it, it's just a variable. Okay?
So once again, you have a case where you have to make the list and then hold a variable reference to it somewhere so that you can work with it.
Exactly, just like we have been doing over and over and over. So let's go ahead and talk about syntax. Well, we've seen the syntax. We've already gone over how to go about creating data members for a class. And this is all it is. It's a variable. So it's going to be a data member. Or it could just be a local variable if you're using one inside of a particular method. But it will look just like this. So, of course, modifiers. And then, of course, list. Now, here's where we get into our generics. Our opening and closing less than and greater than symbol. And then identifier. And then our terminator. Let me clean that up just a little bit. There we go. So there you go. That's the syntax. Now, our modifiers, we already are familiar with the modifiers. If you have forgotten, go back and watch the data members. I mean, you can have public, private, you can have static. The same things apply because this is a data member or a local variable, bottom line. All right, so the key thing that we're going to start focusing on is list and this less than symbol, a T, and a greater than symbol. This is where all of the magic happens, and this is where we get into generics. It's a generic class in the sense that it is going to allow us to work on any particular type that we tell this object to work with. And then it's very strongly typed, which means we're now going to be dealing with that particular type.
Basically, when we make a list, we can tell that list that the list is going to be of type whatever we want to contain. And the key there is that later when we start to work with the individual items, any item that is pulled out of the list is assumed to be of whatever was specified.
That's
so
right.
If we make a whole bunch of enemies, every time we pull an enemy out of the list, it's assumed that that is an enemy, and that means that you don't have to cast or convert it.
Precisely.
So it's not like you pull generic reference out and then cast that to the desired type. Since you've already typed the list through the use of generics, when you pull something out of the list, you know it is of specified type already.
Precisely. So here, to finish off syntax, if you will, here I'm going to come in here and create the list. Tell me if this doesn't look familiar. It's just like creating any other instance of a class. The big thing that's different here is where we're coming in and we're specifying the type. But outside of that, you'll notice we've got the identifier, right? He's equal to a new and that particular type. And within the type, we're specifying the type that it'll be working with. Okay? So let's see this in action. If I wanted to have a list that contained a bunch of enemies, as I've demonstrated through the drawings there, we would have something such as follows. Let me go ahead and push this down just a little bit. So I could come in here and say, I'm going to create a list. Let's all just pretend I wrote the word public, so it's going to be public to everybody. But, of course, I don't have to. So list, and let's say that the enemy class is with a capital E. What am I saying? Here's the class. It's already there. I've already written it out. So list enemy. Now I've got to give it a name. Enemies. Now, of course, I can put a terminator, and this does not create... Hang on, let's just do it. Bloop. That does not create the list. All I have done is created a variable that will hold a reference to an object, but right now it gets initialized to null. There's nothing in it. We're not pointing at anything, so I need to come in here and actually create the list. Now, we have been doing the declaration and initialization, meaning actually creating the particular object or reference on the same line. So let's continue with that tradition. So instead of dropping down to the next line, like in the little syntax example given right here, we'll just do like we've been doing. So I can say equals, and then new list, and again I have to specify what object type are we going to be holding or managing enemy. And just like with any other creation of an object, opening and closing curly or parentheses, excuse me, and terminator. There we go. Now this line actually creates our variable, and this actually creates our instance of the ListGenericClass and puts the reference pointing to it over into our identifier, our variable's name. Okay? And now we have come in here and we have created this scenario right here. Okay?
And personally, I think that's actually the trickiest aspect of using a list, is simply to remember that you have to create the list before you use it.
That's true.
Because since you're working with objects and you're used to creating the individual objects, you're used to creating the enemies, that would make sense. Okay, I have to create 5 enemies.
Mm-hmm.
But you also have to remember that the list, while it is a list of objects, is itself also an object, and you have to remember to create the list before you turn around and use it.
Exactly.
Everything else makes sense. Adding and removing things to a list just makes sense. That's what you use a list for.
Mm-hmm.
But you have to remember that the list itself needs to be created.
Precisely. So now that we have one, of course, what actually is in the list at the moment? Well, there's nothing. So if we were to take a look at the big picture would be, let me think how I want to do this, guys. I'm so picky about this whole thing. The big picture is going to be over on the stack. We have enemies, which is going to be pointing over onto the heap, to our object. Okay, so here's our actual enemies object. But what's currently in it? Nothing. So I could demonstrate that if I wanted to by turning around and utilizing one of the properties that we have available in the ListGenericClass, which is count, which means I could do a console.writeLine. So I could write out, enemies .count. Now, enemies.count at the moment is going to simply return a 0 because there are no objects that we are referencing in the list inside of enemies. So how do we get something in there? Because in the end, that's what the list is all about, being able to add and remove things from it. Well, it's actually very simple. One of the behaviors available in the ListGenericClass is add. So to utilize the method, of course, we could come in here and say enemies dot add. Now, we could just turn right around, and let's say we had already instantiated a spider. We could just put spider in here, and that would drop the reference pointing to spider into the list. But let's say that we hadn't created the object. which is really, in my opinion, far more important because we don't want to have to go in there and create every single one externally and then turn around and put them in the list. Does that make sense, Logan?
Right. If you know that you can just directly drop a new one, like if you can just drop a new enemy,
that's right,
into the list, there would be no reason to make extra variables and just have those variables lying around.
Precisely. So check this out. Inside the opening parentheses, because remember, add is nothing more than a method call, so that means it's going to take parameters. Well, here's the parameter we're going to give it. New enemy. And I know we've talked very lightly about constructors, and that's coming up in the next section. But let's say, Logan, when we defined the enemy class, it'll have a constructor that'll take in a string, and that string will be used to define the name, just like the example we gave where we had Bob and new guy and all that previously. So enemy, coming in here, we're going to send it spider. And simply close that off. And then close off the method and terminate the line. Now what does this do? Well, this now we have spot 0 contains a reference. I'm just going to put a little dollar symbol there, meaning that it's going to contain an address, if you will, that is pointing to the spider. But not only does it do that, it actually created the instance of the enemy class, meaning it just created the spider as well. So as you can see, the spider doesn't exist inside the enemies list, only a reference pointing to him. But this line, new, let me pull this down just a little bit. This line right here works the same way as we've seen 100 times so far. Create a new enemy and send it spider. So the new object, the new instance of the enemy class is created, and we name it spider.
The only difference is we put a reference to that enemy into the list instead of into a variable.
You got it. Because if we had put it into a variable, then we would have needed to turn around and say enemies.add and then give it the variable name. It's an extra step. Why go about doing that if we don't need to maintain a reference to the item outside of the list, right?
Right.
So that is how we can go about adding. So I can obviously turn right around and add a second one, and it would be enemy and then send it Axeman, and then we would have our second guy over here. So let's just stipulate that I did that. And so now our list automatically grows for us. And in this particular case, we'd be pointing over here to Axeman. So again, all simply done with the enemies.add, so the .add method. Okay? Now, seeing how we can go about adding things, before we get into removing, let's see how we can access these things individually. So at this point, let's say I need to talk to Axeman, and I need to know, first of all, I need to know where he is in the list. And there are ways to go about finding where a particular object is inside the list. Now, when I say object in the list, at this point, you guys are going to have to bear with me, and you're going to have to let me speak loosely. And what I mean by that is there's not really an object inside the list. It's only a reference in the list. But it's very easy with just a very generic way of talking of saying, you know, that object in the list, if you see what I mean. So I'm going to say, how do I go about working with the second object in the list? Because for him, I need to have him update or something like that. Well, I could come in here, check this out. What if I was to create an enemy and call it temp enemy? And with temp enemy, now, equals. What do we generally do here? We generally say new enemy, and if there's a constructor, send it whatever data is needed. But I can do this. And I said I wanted to deal with the second one, and since it is 0-based, 0 would be the first, 1 would be the second. There we go. So what does this line do? Well, what this line does is it creates over here on the stack another local variable that's called temp enemy. And I said temp enemy is equal to whatever is in enemies at index 1. Well, here's index 1, so whatever's at this position gets dumped into there. So let's just say it was FF. That's my new way of showing very simplified addressing. Okay, so FF was pointing to this object. So this object, Axeman, resides at $FF. That's his address where he resides in memory. Okay. Well, I have just put FF inside of temp enemy. What does that mean, ladies and gentlemen? Let's all think back to the value type and reference type videos. It means that temp enemy now points to $FF. It is now referencing that enemy object, which happens to contain the name Axeman. Now I can turn around and just treat temp enemy any way I want. Meaning, let's say that the enemy has an update function. I could now just simply say temp enemy dot update. And opening and closing parentheses. Done. Check it out. What's going to happen? Well, Axeman's going to update. So we have called upon this particular object's behavior, the update method to be specific, to execute. Okay? So you can see how this line, or these two lines right here, are getting us to that point. Again, let's just kind of review, because this is very, very important. This is understanding how to access a particular item inside the list. We're simply creating a temporary variable. And this variable is of type enemy. So it's a reference variable. And then we're populating it with information through the use of the equals operator. We're telling it to put in it whatever is in the list enemies at position number 1 or index number 1. Position 0, position 1. What's at position 1? This address. Put that address into temp enemy. Temp enemy now points to the right object. So you can see how if I was to, let's say, do update and then turn right around and say, because temp enemy is now defined, so I could technically turn right around and say temp enemy equals enemies sub 0. Now what have I done? Let's call this $AA. I have now just overwritten the contents of temp enemy with $AA. Now you can see why I picked A's. A lot easier to turn F's into A's. So now temp enemy no longer points to the Axeman because the spider resides at $AA. Meaning that temp enemy now is going to point up here to the spider. Meaning that if I turn right around and perform the exact same code I did above, meaning temp enemy dot update, I'm telling the spider object to update, not the Axeman now. So you can see how basically I can pull out of the list any reference I want. Logan, is there anything you'd like to add into this?
Well, just saying that as you assign things in this manner, for example, as you assign temp enemy to enemy 0, at that point, temp enemy and enemy 0 can be used as the exact same thing.
Yep.
Because they reference the exact same thing.
That's right, without a doubt. Okay, so using this and using what I have taught you previously in regards to loops, we can maybe start to see how a for loop could be very handy for walking through items. Think about it. What if that became our loop counter as opposed to just outright addressing it with a literal number as we are doing here? So let's take a look at creating a loop. So we'll say this is for loops. Well, the for loop. For. Now let's go ahead and put an initializer in here. So int I equals 0. While I is less than what? That's less than, I promise. Okay? We want to loop through all the enemies. So while I is less than, we have that available, don't we? Right here. Count. Count's going to tell us how many items we have in there. So while I is less than enemies dot count. And so while it is less than enemies dot count, we'll continue walking through the loop. Then, of course, we can simply do I plus plus. Ooh, I have just defined a loop that is going to allow me to walk through all of the items inside of a list without any problem. But let's do something with it. So inside the list, let's stipulate that I've already created temp enemy. I defined it outside of the loop. I could just turn around and say temp enemy is equal to enemies sub I. Check it out. Our index is changing as we walk through the loop each time. It goes from 0 and it continues to grow. So that is going to point to a different object each time we iterate through our loop. So now I could turn right around and, tell it to write out, let's say that the enemy has a public name data member. So I could just say write out the temp enemy dot name. Terminator. I could call upon its update. I could do whatever I want with it because right now I am holding a reference to that particular instance, the object that I need to work with. And then I can go ahead and close off my for loop. So let's pretend for just a second that we're using the example on the left. This one right here. I is going to start out at a value of 0, right? So I starts out at 0, and then, now I'm not going to keep jumping down here, but just let's remind you of what's happening. We're going to be looking at enemies sub I, and we're going to pull that guy out, that address, and we're going to store it over here in temp enemy. So keep that in mind. So let's pretend temp enemy is right here. It's over on the stack. It's sitting there. So the very first thing is I is equal to 0. That means we're looking right here. So let's pretend that this is $A, $B, $C, and $D. For those of you that are not familiar with working with addresses in a computer, these are horridly simplified. Please, this is just for demonstration purposes only, and please do not believe that these are actual addresses. Okay, so I'm pointing at 0, so I'm going to, inside temp enemy, store what is at enemy sub 0, since I is currently at 0. So I'm going to store $A in here. Which means if I now say temp enemy.update, I am updating the spider. Okay, or if I say print out that enemy's temp enemy.name, I'll be printing out spider, if that happened to be the name I sent in. Now what's going to happen? We iterate back up through the loop. I becomes, plus plus, so I becomes 1. So it goes from 0 to 1. And now it says, is I, all right, like I said, I'm not going to keep going down here, but just a reminder. Our condition is as long as I is less than enemies.count. So as long as I is less than, well, what's the enemies.count? How many enemies do we have in the list at the moment? We have got 1, 2, 3, 4. So as long as I is less than 4, we're going to continue iterating through the loop. So I is now a value of 1. So it was 0 there. I is now 1, meaning we're pointing at $B. So what are we going to do? We're going to simply put temp enemy. We're going to populate temp enemy with what is at enemies sub 1, which is $B. So now if I turn around inside the loop and say, well, let's go ahead and print out temp enemy, it's going to be pointing at the Axeman. So we'd print out Axeman if that happens to be his name. Then we'd go back up in the loop and we would increment I, so I now becomes a value of 2. And then we would check, is 2 less than 4? The answer is yes. So inside the loop, we would now say, set temp enemy to be equal to enemies sub 2, because that's what's in I. So we would now hold $C inside of here. And then after that, if we were to say temp enemy dot show me your name, we're looking at the dog. Once again, we go back up in the loop. We increment our I from a 2 to a 3. We increment it by 1. So now is 3 less than 4? Yes, it is. So once again, we say temp enemy is equal to enemies sub I is a 3, so we're going to put $D in temp enemy. Meaning that temp enemy is now pointing to the bird. The crazy evil bird. So now if we say print out the name of temp enemy, we'd print out bird. Okay. Now what are we going to do? We go back up in the loop again. We increment, once again, I. So I gets incremented by a value of 1, meaning that it becomes a value of 4. And then we do our conditional check. Is 4 less than 4? No. False. 4 is equal to 4. Now we're done with the loop and we skip out. So there you go. We've just traced through a loop accessing our items individually based off of the index being controlled by the loop. Very, very powerful stuff. But there's another loop. Oh yeah, and let's just not forget, you can walk through entire lists, you can walk backwards through lists, you can walk through a part of a list. It all comes down to how you define the loop. So don't forget, everything that you've learned in the past about controlling loops, it all applies here, okay? So you're not limited to just this very simple example. You could have a very complex loop set up. Okay, the bottom line is, though, you're just controlling this index that you're going to use inside of the list to gain access to particular items. Now, we have another kind of for that we can use that is even simpler. If you know that you're going to walk sequentially through every single item in the list, you could use a for each. And for each is very simple how it works. Before I write up there, let me look. Is there any more room down here? Ooh, it's tight. But it's possible. So let's just squeeze things up just a little bit. Squeezed. Okay, so here's how this other loop works. Basically, it is for each, all lowercase, all one word, opening parentheses. Now inside, the first thing you're going to need to do is define the type that you're going to store the reference to of each one individually. Meaning, enemy, and then we need to give it a name. In, now we need to give it a list. In enemies. It's that simple. Now, just because I've run out of room to do opening and closing curly brace, let me tell you that we're only going to put one statement inside this for each that we've just created. So if you're using only one statement in a loop, you don't have to have the opening curly braces. We all know that now. So I can now come in here and work with enemy. So it'll be enemy dot, let's say I'm going to call upon update now. So here I have created a very simple loop that will walk through every single item in the list, and as it gets to each item, it puts that item from enemies into enemy, and then it allows me inside the loop to do some work with that particular item from the list. So in this case here, all I'm doing is calling upon enemy.update. Then, internally, the for each does all this for you. It's really cool. After we get done with doing inside the loop, which in this case is just enemy.update, for each then goes, okie dokie. Do we have any more enemies in the list? Well, yes, there's another one. All right, well, let's take the next enemy and put him into enemy. And then we do the contents inside the loop again. So we come back in here and we update the second enemy. Then once we're done doing the contents of the loop, once again, we come back up here, and this is just all built in automatically. The for each asks itself, is there any more enemies inside the list? Well, yes, there is. As a matter of fact, we've got 4. All right, fine. Take the next one. So the third one, put it into enemy. Now we come back down into the loop, and we can work with that particular instance. Once we're done, we come back up, and for each asks itself again, is there any more enemies? Because for each just happens to sound like that if you could understand computer talk. And of course, it's like, yes, there is. We've got one more left. Well, fantastic. Give them to me. So the fourth and final one gets copied over into enemy. So enemy is now pointing to it. And we can then, inside the loop, address him. Then when we come back up, is there any more? No, there's not. We've gone through all of them. Well, thank you very much. Have a good day. And we exit outside of the loop, and we continue on with whatever code is left. Okay? So that is the for each. It's very powerful. It's very simple to set up. Okay? The big thing to remember in creating the for each is the syntax is definitely different than the regular for loop. It's for each and then type and identifier. That's the key thing. This type and identifier, you are creating a local variable, a block scope variable for this for each right here that is going to hold each reference one at a time as we walk through the loop. Is there anything you want to add to that, Logan?
You can actually compare it against a standard for loop, because if you look at the definition of the for each and compare that with the initializer of a regular for, you can see some parallels. If you look at the initializer in the original for loop, you have to specify a type and an identifier for the index.
Right.
So you can compare that against the for each where you have a type and an identifier for actual items.
That's right.
Basically, a for loop is an index-based loop. So you have to specify your index and what type of index it is and how the index works. In a for each, you have to specify what kind of items are we going to loop through. So it's like an item-based loop versus an index-based loop.
Right.
And you can even, or another way to look at it is with the where we define enemy equals so like type of the variable and then the variable itself. If you go back to the for loop example and put the type in front of temp enemy, you could use that to compare it as well. So if you put enemy temp enemy equals enemies.
Oh yeah.
So it's like an automatic version of having this line, except that this line now drives the loop. So instead of enemy temp enemy equals the indexed enemy we're looking at now, instead enemy equals whatever enemy in all of the enemies.
Right.
So that way you directly use that line immediately and have it available instead of having to look it up based on index later.
Exactly. And the for each is kind enough to manage the whole thing. Basically start at the very first one inside of the list. And so what's going to happen is we're going to start at the very first one, pull it out, stick it in the local variable that we define in the for each. So put that reference in there. Let us work on it. Go back in, identify that there's still more, pull that one out, put it in so it gets replaced. So we can now reference that one, then the next one, then the next one. It's just going to keep doing that until it has walked through every single thing that is inside the list. Okay.
Which is more convenient and less error prone. If you know that you have a loop and you want that loop to walk through all enemies, it's easier to use a for each because the for each is just by nature going to access all of the enemies.
Exactly.
If you're using a standard for loop and you're setting up the index yourself, you have to make sure that index range is correct, that it doesn't go out of bounds on the list. Otherwise, you end up with an exception. You either have an exception if you go out of bounds, or you have improper behavior if you didn't access enough of the elements. If you leave off the very last element, then you have a logical error, which is even harder to track down because it doesn't throw an exception.
Translation for anybody that may have had a hard time following what Logan was saying. Setting up this kind of a loop is very easy if you're not paying attention to have problems in your logic. Okay? So, I mean, if you had to do something like I is less than enemies dot count minus 1 plus 1,000 minus, you could really mess up what you're pointing at. So there's definitely room for error here, where inside the for each, it's error proof. Basically, it's going to handle walking through, starting with the first enemy or the first item in the list. It's going to handle walking through every single one. Okay? Very good. Okay, so just a couple more things that I'd like to introduce, and then I'll have Logan code all this up so that you can see it in action inside of Visual Studio. Let's go ahead and talk about removing. And Logan, I don't think I can squeeze much more on. Not without it becoming super crazy confusing looking. Not that it isn't already. All right, so for removing, there's two different methods I'd like for us to take a look at. Basically, let's take a look at remove and then over here, let's take a look at remove at. All right. So first of all, let's say that we do indeed have a local variable that is pointing to a particular object that we know is inside of the list, and we want to remove it out of the list. Well, simple enough. Let's create that scenario. So if I had enemy and target enemy. enemy that I want to eliminate from the list, equals, let's go ahead and assign him to somebody that's in the list. So enemies sub 1. All right, now enemy sub 1 and target enemy are both pointing to the same object. Now I could just turn around and say enemies dot remove, and being a method, I now have an open parentheses, and I can just feed it the target enemy. And close. And that will remove that item from the list, and everybody else will simply fall down to close up the gap that was just left inside the list. Now, let's go ahead and let's create another really quick scenario, an image if you will. So here is our enemies list, and inside of it it's got 0, it's got 1, it's got 2, it's good enough. This is our spider. This is our Axeman. This is our dog. And they happen to be at addresses $A, $B, and $C. So that's the references we're going to store in here. So $A, $B, $C. So we're now pointing to them. All right, so now everything is established properly. So now, at this point, utilizing what we just did up above, what is this doing for us? Well, it is creating a local variable called target enemy. And in target enemy, let's go ahead and put that in. Inside of target enemy, what we're going to do is we're going to store whatever is at enemy sub 1, which happens to be $B. So $B goes in here. That means that this guy is now pointing at this object. So he's holding a reference to that object. And then I'm going to turn around and I'm going to call upon enemies, and I'm going to send that target enemy into its remove method. So it knows, okay, it's got target enemy. Well, target enemy holds that reference over here to $B, so it knows to go through itself, locate ding, 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 $B, remove that reference, and everybody else closes up. So $C, this goes away.
That's one important thing to keep in mind, is that you will never have gaps in a list. If an enemy is removed, or if an item is removed from the middle of the list, then the indices shift so that everything is contiguous.
That's right.
So if you can't rely on index 3 pointing to an actual enemy. If enough enemies are removed so that you no longer have an index 3, there just won't be one.
That's
all
right.
the other enemies will shift. So never hold the indices as an absolute value for which enemy this is.
Precisely. And so there we are. This is what it now looks like after executing those two lines above, up under the remove heading, right here. Basically, if we were to turn back around right here and write out enemies dot count, the count would be what? It would be 2. Because there's only 2 things in the list right now. And then if I was to tell it to, well, let's go ahead and get whoever's in position 1 right now, or index number 1, and print them out, we would find that where it used to be the Axeman, it is now the dog. Okay? So that is remove. Remove that, a little bit simpler. Let's go ahead and take a look at how remove that works. So I'll draw a little line right here. And it looks like this. Basically, enemies dot remove at, and then it takes in one parameter, an index, that's this, or an integer, and let's say we want to remove out 0. And terminator. That's it. So remove at 0 means remove at index 0. Who's at index 0? We're currently pointing to this guy right here. So if we remove him out, the reference to $A comes out. We're no longer pointing over here. And what happens? Well, what was that? $1, because everything has to close up to stay nice and neat, goes up here to the first spot. So $C goes up there. And this is eliminated, which means index 0 is pointing down here. So now if I was to say enemies.count, what am I going to get? I'd get a 1 this time because there's only one thing in the list. And if I was to say, all right, fine, give me that particular enemy and print out its name, what's it going to say? It's going to say dog because that's what I'm pointing to at the moment. Okay? So that is how to use remove and to use remove at. And that, Logan, is everything I wanted to cover before we get over into Visual Studio. So let's jump back over here. Let's see. Did we do a good job? Oh, yeah, not bad. We've kept it relatively short, too, so that's good. So we have seen what exactly list generic classes are. We've taken a look at the syntax. We've talked about working with lists. We've seen how to create them. It's just creating an instance of a class, that's all. The key thing here is we're specifying what type we're going to be dealing with in the list. And the type could be an object type. It could be a string. It could be an integer. Now we saw how we can go about adding items into the list, removing items, accessing items individually. We saw how we could get the count of how many items are in the list. And I talked about 2 different loops. We looked at how to use the standard for loop, and I finally got to show you the for each loop that we can use to walk through each item in the list. So that, Logan, is everything that I wanted to show here. Let us go ahead and jump over into Visual Studio now, and let's put together an enemy class, and let's see if we can build this whole thing.
Okay. So let's switch over to Visual Studio, and let's begin a new console app so that we can try some of this out.
Okay. So we'll start out jumping down up under the program class and start a new class called enemy.
All right. We've got class enemy.
Okay, and inside class enemy, let's go ahead and create a public, instead of worrying about creating properties and all that, we'll keep this as streamlined as we can.
Sure.
So let's go ahead and make a public string name. So we're making a public data member called name.
All right, public string name.
Okay, and now let's go ahead and create a constructor real quick. Now remember, the constructor is a special method that is available in every single class. Rather, if you don't define it, then the compiler is going to put it there. And like I said, we're going to talk about constructors coming up really soon in this next section. But let's go ahead and create one.
All right, let's have a public enemy, so I'll have a public constructor, and let's make that constructor take in a parameter.
So just string name with a lowercase n. All right. Now, inside it, all we're going to do is initialize name with a capital N.
So we'll set the public name field to be whatever string was fed into the constructor. In this case, the parameter name.
So by having this constructor in place, all we're saying is every time we instantiate the enemy class, we must pass it a name when we instantiate it. We must. Okay, so, I mean, constructors are really simple. It is that simple, guys. Okay, so now let's go ahead and make an update method so that we have something to call in our loops.
Okay. We'll make this public so that we can access it. It doesn't need to return anything, so it will be void, and it will be called update.
And inside of it, just do something along the lines of a console.writeLine and say updating enemy, and then append to it the name.
All right. Updating enemy.
Colon, and yeah.
Now we'll append to it the name field, and that should take care of that.
Awesome. So that's enough functionality inside the class. So with that, let's go ahead and jump back up inside our main method.
All right. So back inside of main for our program.
All right. First, since we're studying how to use these list generic classes, let's go ahead and instantiate a list. So first, in doing this, we need to make sure we define the variable that's going to hold the reference to it. So let's go ahead and do a list. And now let's do the less than symbol. And what type does it hold? See, right there you can see, check it out in the little pop-up. So class system collections, it's a collection definitely, .generic.list and T. So the type, and the type in this case is enemy.
All right, so we'll put down enemy for our type, and then close off the brackets.
Now let's give it the name enemies.
All right, the name will be enemies.
Equal, so now we're going to, that's basically creating the variable. Now let's go ahead and create the actual list. So new, list, and then let's go ahead and feed in the type again, and the type needs to match, so enemy. And then opening and closing parentheses, because, again, this is calling the constructor for the list class to actually instantiate it, and then terminator. Beautiful. All right, so next one, go ahead and do a couple forward slashes and just put the word count.
All right, so this will be the count.
So here's how you can go about using the property count. So just do a console write line for me and put total number of enemies.
Let's write out total.
That's a funny way to spell total.
It is. It is indeed funny. That looks better.
There we go. So total number of enemies.
And then we'll append to that.
So here we are using the list now.
All right. So enemies are list dot count.
Very nice. And you can see it as a property there with a little graphical indication inside of IntelliSense. So count.
So we can end off that. End off the write line.
Okay. Now just do another write line just to kind of put some spacing in here.
So just write out another blank line.
Okay. Now jump down a couple and give me 2 forward slashes.
Oops. All right. 2
and put add. We're going to show how to use the add method now.
All right. Add.
Let's create the spider, the axeman, and the dog. So enemies.add.
All right. Enemies.add.
And then inside here, now it's looking for us to add an enemy item. So we don't have any enemies to actually add because we have not instantiated the class yet. So let's do it inside of here. So we can simply do a new enemy. And now see, of course, enemy is expecting a string because there's a constructor that's been defined expecting a string to come in. So let's go ahead and call this one spider.
All right. This will be our spider. And that takes care of the constructor for the enemy.
And then let's go and close off the add. There we go. And then terminate. And then you can copy and paste that line 2 more times and change it to Axeman and Dog.
All right. We have an Axeman and a dog. So there is our dog.
Okay. Now go ahead and copy the 2 lines up under count because I want to show that we've gone from 0 items inside of the list to having 3 items in the list. So let's go ahead and build real quick, make sure the solution builds.
All right, so F6 will build, and everything succeeded.
And let's go ahead and put a read line at the very end of our main method so that we can hold execution until we hit enter. All right, and let's run it. All right, check it out. Total number of enemies, 0, before we actually put anything in the list. As a matter of fact, if I take this and just move it on out of the way. All right, so we create the list, but we haven't put anything in the list. So then we turn around and we print out the total number of enemies at the moment. Total number of enemies? Nobody. There's 0 because we haven't created any. So now, I won't say created, we haven't added any to it. So now we're going to add some enemies to the list, and in adding them, we're also instantiating at the same time. So this is where the items truly get created over on the heap. So we create a spider, an axeman, and a dog, and we put them inside of enemies, inside our list. So now when we say the total number of enemies, check it out. There's 3. Okay, so now we can see this is indeed working. Very good. So let's go ahead and close that out. So drop down a couple lines for me and do me 2 forward slashes and retrieving an item by index.
Okay. So retrieving an item by index.
All right. So now let's go ahead and define an enemy local variable right here.
So, fix that. There we go.
Okay, so enemy.
Enemy.
And you can call it temp enemy.
So temp enemy.
Equals. Now let's point him to somebody. Let's point him to, let's say, the dog. So we could say enemies and then a square bracket. So look at that. The IntelliSense is telling us that now it's looking for an index. And at the bottom, it's giving you a little message saying that the 0-based index. So that's very important. It's 0-based. So 0 points to spider, 1 points to axeman, 2 points to dog. Well, let's point it to the dog. That would be 2. Okay? So now we can turn around and let's update the dog.
Okay. So let's take our new temp enemy variable and tell it to update.
See how simple that is? At this point, we can now, temp enemy is pointing to the dog because we pulled that reference out of the list and put it into temp enemy. So if we run it, now remember, if we look down here, what does update do? It simply writes out updating enemy and it's going to give the name, and the name should be dog, so it should say updating dog. Let's go ahead and run it and find out. Ooh, 0 before, 3 after we've added, updating enemy, dog. So now we are actually updating the right object. So we're pointing to the right object. Very cool. All right, let's go ahead and jump out of that. Okay, so that is how, right here, you go about using the index inside of the list to pull out a reference. And then we're just storing that reference in an object of that type. All right, so now, object of that type, an object that we've set up, a local variable that we've set up. There we go. I'm going to find some terminology I like sooner or later. All right, so let's go ahead and jump down a couple of times. And now let's take a look at a loop. So 2 forward slashes and call this the for loop.
All right, so a for loop.
All right, so let's set up the loop.
All right, a syntax for a for loop. We'll do for, and then open parenthesis, and then initializer int I equals 0. And the condition will be as long as I is less than enemies dot count. So we can go through all of the enemies. And then as we walk through, we want to do I++ to increment I.
Okay.
And then we'll bracket in the for loop.
All right. So inside of here, let's go ahead and do exactly like we did above. We could just use temp enemy again if you want to just say temp enemy equals.
Or enemy.
Or we can create.
Okay, reuse.
Yeah, I was saying we could just reuse it since it is indeed still within scope.
Sure. All right, so we can just use our existing temp enemy.
Mm-hmm.
And now let's change its reference over to enemies sub I.
I love what Logan just said. I hope you guys were paying attention. Let's change the temp enemy's reference over to another item, or to whatever item we're currently pointing at. And that's exactly what's happening here. I is going to start out initialized at 0, so we're changing the reference in temp enemy, because remember, it was pointing to the dog. We're changing the reference in here to point to the very first item, the spider. So very good, very, very good. All right, so now let's go ahead and write out.
All right, we'll write out.
And then just put the selected enemy is, because this is the enemy that, it's kind of like we've selected. It's the one we're working with. And now since we've made name public, let's just go ahead and concatenate temp enemy.name.
Temp enemy.name. There we go.
And very cool. So let's go ahead and run this and see what we get.
Though what I'm thinking here is that this is actually going to go out of bounds, but we'll see. Let's try to run.
Oh, as long as it's less than that number, it won't go out of bounds. Yeah, what you thinking? Because, well, it's less than count. So there's 3 things in there. So it'll go for 0,
I was thinking
go
of
for
the
1.
other one. Yeah, I got you.
I got you. All right, so let's go ahead and run it again so they can see the number. All right, very good. So check it out. The selected, so here we are updating dog, and now we've got the selected enemy is spider. The selected enemy is Axeman. The selected enemy is dog. So we've walked through all 3. So again, the convenience of having a loop and being able to iterate our way through a list of objects, which means we now could have each one simply update or do whatever we needed to. Like we could walk through all of the objects and check their health. And if somebody's health happens to be below 0, we can kill them or remove them out. So very, very cool. All right, let's go ahead and close that. All right, so now that we've seen that, let's go ahead and take a look at the for each loop. We'll use the for each loop to actually update it. So do me a console.writeLine. Actually,
if you want to get a
just to get a blank line. Let's copy that one up there, and let's use it after this guy right here as well.
So back up over here?
Yeah, there we go, and use it one more down after the for loop.
Just to kind of space things out a little bit.
We're just spacing it apart so everything's easy to read. All right, so let's use for each. So it starts out with for each.
Now let me drop down a comment. This will be the...
good idea. For each.
All right.
So we start out with for each. And then inside of it, the first thing that we do is we define a local variable of the type, so enemy, in, and then enemies, our list, our collection. All right. So now inside of for each, so Logan will go ahead and set it up. Let's just say enemy.update.
All right. We've got enemy, which should be a block scope variable pointing to any specific enemy. And, of course, it's an enemy, so it can update.
Very nice. Let's go ahead and run this and see if they've all updated. All right, and they have indeed. So check it out. 0 in the list, 3 in the list, pointing to dog. Then we walk through the first loop, and we've printed out the name spider, axeman, and dog. And then we just used the for each loop where we have updated the spider, updated the axeman, and then updated the dog. Very nice. So as you can see, the for each was extremely quick and easy for Logan to set up. That's all there is to it. All right, so now that we've got that in place, I guess the only thing left we need to take a look at is removing. So let's go ahead and to another console write line. Keep things nice and clean. And in here, let's do a comment for remove.
All right, this is going to be the remove.
Okay, and now let's go ahead and we can just use temp enemy again.
Alright, so we'll take our temp enemy.
That was defined up above. And let's set it to enemies sub 1.
Alright. Enemies, there we go, sub 1.
And who are we pointing to, guys? Think about it. Think about it. We're pointing to the Axeman. That's right. 0 based. Okay, so on the next line, let's just say enemies.remove and remove our temp enemy.
So enemies.remove. We'll feed in the temp enemy. And there we go.
Very nice. All right, so now give me another console write line.
Write line. All right.
And now you could go ahead and, after that write line, do another write line that says enemies after removal.
All right. I've got enemies after removal.
Okay, now copy the whole for each above.
Yeah,
copy that guy. And paste him right after enemies after removal. And change it from enemy.update to be write line, and inside of the write line, just write out the enemy.name.
So I'll write out similar to... I can steal the one from the first one, because that's where we were printing out the enemy name.
You could do that. You just got to go change where it says temp enemy to say enemy now.
Because we're, of course,
That's
using
right.
the local variable inside the for loop.
Yeah,
So
you can take I was going to take all that out. I was just going to have it say...
Like that?
Yeah, like that. So, real quick, what's going on right here is basically we're pointing over to the Axeman, then we're removing the Axeman, and then Logan's just got a blank line pushing us down, and then it's going to, which technically we don't have to have that in there. And then it's just going to write out enemies after removal, and it should say spider and dog, because Axeman's been removed.
All right.
And let's find out what it says. So, enemies after removal, spider, dog. So, Axeman has indeed been removed. Very nice, very nice. All right, so that's how to use the simple remove method. Again, it's just the list.remove, and then the parameter that it's looking for is a local variable of the enemy type that's pointing to one of the ones to be removed. Okay, so next thing, let's go ahead and do another write line down here, just to keep some spacing in there.
I'll keep stealing these write line lines. Whoops, not page up. We'll just paste that in.
Okay. Now let's go ahead and say enemies.remove at, and let's remove the spider, so 0.
So enemies.remove at, we'll specify the index of 0, which should take away the spider. And,
and now we need to just simply have another, just copy that, that whole section right there, and paste it in. So again, after he removes index 0, which is the spider, then it's going to say enemies after removal, and it's going to walk through our list, and it's going to print them out, which the only thing we're going to have left is the dog. So let's go ahead and run this. There we go. Enemies after removal this time is just the dog. So the spider did indeed get taken care of. Okay. So is there anything else that we wanted to add into this? We could show clear. We could go ahead and just throw that in as a bonus right now. Basically, how do you clear the whole list? So let's just do enemies.clear.
All right, enemies.
So our list.clear.
Clear.
And then let's go ahead and steal the line from above that says number of enemies in the...
So way back up at the top where we have total number of enemies.
Yeah, that sounds good.
We can steal that line and place that directly after the clear.
Okay, so there should be 0 at that point. Let's go ahead and run it. Look at that. So enemies, dog, and then we clear the whole list, and with the list empty, total number of enemies, 0.
Obviously, the key being there, since we only had one left, we actually had an option. We could have done a remove at 0 again. That would have removed the last, resulting in 0 enemies. Or in this case, we did clear. The only difference, obviously, being is that clear would take out any number of enemies. If we had done clear from the beginning, when we had 3 enemies, that would have taken us back to 0. Because, again, just clearing the list.
Exactly. Now, for dealing with errors and bounds and things like that, that's something we're going to be talking about a little bit later. So right now, make sure you're responsible when dealing with a particular index, that you know that you're within bounds. So, because we're going to introduce some more concepts when we get to that stage. But I think this is going to take us to the point where we've got everything covered that I wanted to have covered to introduce you to working with the ListGenericClass. So looking back over here at the board, and yeah, that's everything. So that is going to wrap up this video. Fear not, we're going to turn right around in the next video, revisit the bouncing X's, and we're going to add in the list so that we can have multiple X's bouncing around the screen, all taking care of themselves without us having to code specific code to address each one individually. So just using the power of the list. So with that, that is going to wrap up this video. Thanks a lot.